Okay, so on this video, we're going to focus on the higher order polynomials, so 3, 4s, and 5s. So we're going to go ahead and get started on this one. Now, this one is an easier one because it's already in factored form, so that's going to save you some work. Now, the first question is, what is the degree? So as I told you in the other videos, if you've been watching those, guys, as you do this and I ask you questions, I am going to pause slightly, and I really hope that you hit the pause key and think about the answer, try to write the answer down, and see if you get it right. Because again, the only way you're going to know whether or not you truly know how to do these problems is if you do it. Don't just watch me do it, okay? You need to do it yourself. So again, I will ask you the question, and then you can see if you can answer it. The other way, guys, would be jump in there, just do the problem on your own, then watch the video, watch me do it, and just check to see if you're right. Okay? So again, I hope that as you're watching this, that you are watching it with sound, not just watching the work. Because again, hopefully, you notice that I try to elaborate some, add in some extra facts, and so forth. So let's go ahead and just get started. So the first thing is, what is the degree of the polynomial? Okay, so hopefully you said that this is a degree 4. Now, how do I know it's a degree 4? Well, if it is already in factored form, what you need to do is just count up your exponents. So 2, 1, and 1. Okay, so a degree 4. Now, in behaviors, if it is a degree 4, what are your end behaviors going to look like? What's your graph going to look like? Okay, so I'm going to go ahead and jot this down. As x goes to a negative infinity, your y is also going to go to, what am I doing? I'm doing a 4. Your y is going to go to a positive infinity, okay? If I do a quick sketch of my graph, remember that's the one that kind of looks like a W, or it could look like what we just did and be a parabola type thing. So both are going to go up, okay? So as x approaches a positive infinity, y is also going to approach a negative infinity. I do want to make a quick comment real quick, because I have saw some of you, not many, but some of you putting the arrows in a bunch of weird places. Weird, I don't know why that's not working. A bunch of weird, one person did it in interval notation. Guys, the only time you see the arrows is when we are doing the end behaviors. For in here, that's the only time we're going to see it. Okay? So when you go on to calculus, you're going to see where they do it with the limit, and you'll see that arrow again. But in here, the only time you're going to see it is with the end behaviors. And we're meaning as x approaches. That's why we need that. You're not going to, so it shouldn't be anywhere else in your problem. Okay, so the next thing is, given this problem, what would be our y-intercept? Okay, so again, when we go to find our y-intercept, remember, we are going to let the x be 0. So again, our function notation. So we have 0 minus 2 squared. We have 0 minus 1. And we have 0 plus 3. So really what this is going to give me is a negative 2 squared is 4 times a negative 1 times 3. So f of 0 in this case is a negative 12. Or as I've told you before, it means the point 0, negative 12. Okay, so we've got our y-intercept. Now the next thing we're going to do is find our x-intercepts. So again, since this is already factored, okay, since it's already factored, this is where your y, or it, whoops, excuse me, your y, or your, in this case, f of x, is equal to 0. So if f of x equals 0, then this equation will equal 0, which in turn means that each of my factors will equal 0. Okay, so this is x equals 2, x equals 1, and x equals a negative 3. Now, there's one slight thing that I still need to do in terms of my factors. Can you tell me what else I need to write on my factors or on a factor? Okay, and hopefully your answer is that this has a multiplicity of 2 because of this equation, or this exponent, not equation, this exponent. Okay, so those are my answers. I could also rewrite those as negative 3, 1, 2 with a multiplicity of 2. Okay, so now let's get started and let's put all this on the graph. Now, due to the fact that I could actually get this on here, and again, I will try to watch what I give you on the test, but we're going to graph 0, negative 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, there's my number. I'm going to graph a negative 3. I'm going to graph 1, and I'm going to graph 2. Okay? Now, again, remember what my graphs look like. It's going to be something like that with my end behaviors up here and up here. Okay? The other thing that I would write on my graph is what happens at possibly each of my x-intercepts, but in particular, what happens at 2, more so than any of the others. So, did I graph those right? Yeah. So, oops, I didn't graph those right. I need that at 2. I put it at 3. Whoops, sorry, my bad. Let me get that back in there. Okay, so uh, 1 and 2. Yeah, those are really close together. That's going to be... Okay, so we've got it at 2. It's going to touch and bounce. So I'm going to put a little B there. Okay, so if I go to graph this, so I'm going to start up here where I already have my arrow, and I'm going to come down, and I know it goes through here because it doesn't touch and bounce. I'm going to go down to, and since I really don't know what's happening, I'm going to go ahead and turn around at my intercept. Again, it could have gone on down here and then come up. That's an option. Or the other thing is that it could also have gone on through here, but more than likely not, because again, I've got to make it back up to that 1 pretty quick. So definitely it's a possibility, I'll put that back, that it could have done that. Okay, anyway, either way, it's going to come on back up here. It is going to go down through there, up through there, sorry, and then it's got to come back here and touch and bounce. Okay, so we're going to have a graph that looks something like that. Okay, now, one of the things that I did not put on this one, I do put on some of the ones later on, but you do also need it on this one, is local minimum and local max. Now, in class, we talked about that in order to actually find exactly what the local minimum and the local max is, we would need to use our graphing calculator and our trace function and figure out where that point was. Since I have told you you're not allowed to use your graphing calculator on this test, then the most that we could do is tell me the interval in which it occurs. Okay? So if you look at your graph, where is the minimum point? Okay, well, we know it's going to be somewhere down here. okay? Whether it's right there or whether it's on down here, we know it's somewhere there. So all you can tell me, the most you know, is that it is between these two things. So we would say the local min is between a -3 and what is that, 1. Okay, it's somewhere in between there. Okay, the next thing that we would say is, where is our local max? And let me go back to min. Now I have a minimum here also, right? But we know that that only goes down to 0, so there's no way it is in there. And the other thing is, when we talk about our minimum and maximum value, normally we give a y value, because that's this would be our min and max, would be up and down. But because we don't know a specific y value, we're only saying in this x interval you would find the y value that is the minimum. Okay? So the same way, if I go to find the local max, then I know between these two, there's going to be a max up here somewhere. So that would be then between 1 and 2, that interval, we would find our local max. Okay? Hopefully that makes sense. So I'm not asking to find an exact value, exact y value. It is possible, according to what the graph looks like, you will be able to give me a local minimum or a local max, just according to what your graph looks like. But more than likely, you're just going to give me the interval. Okay, that is my graph. Again, as you're doing these, guys, I would also note any questions you have, so that when you come to class or whatever, or you can email me if you have a question and say, hey, when you did this one, where did this come from?